Hi, YouTubers. Dave out in Western Pennsylvania, USA. We just started an interesting, at least I find it interesting, cycle of charges and discharges with commercial Supercap. I get them from Amazon. 2.8 volts, 100 farads capacitance is reported with an initial estimate where I did delta V over delta T. I get about 93 farads, so seems to be okay. That was the first approximation. I have one in a circuit with an E-load machine. I've described this ZKE Tech in many of my other videos. And I'm doing a cycle run. I'll get back to the chart in a minute. In the circuit in series, it's very important that you have it in series, not parallel. We have in a sealed plastic bag, this is a dry circuit run that I'm doing here. Dry circuit. And I define that as the graphite felt in this case that I'm using has not been cleaned in any way, used directly as is, and it has not been in contact with a deep eutectic solvent or ionic liquid or either one with, let's say, lithium bromide as an electrolytic solution. So this is simply a dry run here. The dimensions of the graphite felt. First of all, it is conductive enough for applications with supercaps, and I get about 9 ohms per centimeter uniformly all over the surface, both sides of this commercial felt. The thickness is 2.9 millimeters, plus or minus 0.1. The width is 5.5 millimeters, and the length is 40.4 millimeters, measured with a caliper. Sealed in the bag with 18 gauge copper leads. This is inserted into the circuit through the negative feed, the black. That runs then to the supercap, and it's in series. So the graphite is connected to the black, that is connected to the negative of the supercap, so it's in series. Very interesting, because when you look at this initial run, I will post the performance of this supercap without the graphite. I've done a prior run. And if you look at my parameters, I'm charging up at 750 milliamps, and I'm bringing it up to 2.90 voltage with a trickle charge, a cutoff at 0.20 amps. A wait period of 1 minute, and then I discharge a constant current at 250 milliamps. And I take it down to a cutoff of 0.30 volts. I wait a minute and then 75 cycles. Now, if you look at the data, the Coulombic ratio, the capacity, is starting to smooth out. Let me scroll down. And if you look at 3-3, 3-1, so 0.017, 3-1 to 3.3, 0.021, 4-1, charging up at constant voltage, 0.023, and then 4-3, discharge, 0.021. It's starting to smooth out. Now we want them to have a ratio of 1-to-1. And that means we're losing minimal energy as heat. Now look carefully at this graph in the beginning. And you can see the red line indicates smoothing out as we progress. Starting to smooth out stepwise as it drops down through trickle charge current to 0.0 220 current. So you can see in the beginning it's very rough, and it actually is jagged. It goes up and down, and that's probably because of the graphite in the circuit, oxidation of contaminants on the surfaces. Now, something else I have to point out. This graphite, even though it's being run dry, I have sprayed it 3 coats of aerosol graphite on each side with a wait of 15 minutes between coat application. Aerosol graphite has been sprayed on the top and the bottom of the graphite, and then I let it dry overnight. There's about a 12% mass increase due to graphite deposition. Now, we'll be examining this with scanning electron microscope. Now, why did I do this? I want to see if I can increase the surface area by applying a thin coat of aerosol graphite. We're also going to be nickel plating on top of that, but that's another experiment. So, what we did first yesterday, we ran this graphite with a power supply. I've had videos on that, with an LED load, electronic load, and I left it in there, hooked up in series with the LED, and at 3.9 volts, the current was 0.09 amps, and it stayed pretty steady. So I did a dry run first with the power supply, 3.9 volts, constant potential, and I did not see any serious fluctuations. Now, that could be that most of the resistance, of course, is coming from the LED lamp, but I still wanted to run it in series before actually conducting this experiment. But the DCC and CCV, they're starting to converge, which is very good. I want to see how the graphite will perform in a circuit with a commercial supercap. Now, the next thing would be a wet run where I will apply a DES electrolytic solution to this graphite and then run 100, 200, 300 cycles looking for any aberrations. We'll keep you posted on this. Thank you for watching. Bye for now.